Yeah, so we can take some questions for Bob and Dan, and maybe if we could ask that people say who they are when they ask a question, would be great.
Roger Anderson from Vermont, and Bob, you were right, of course. I ran the design and lobbying program, and we had it on the schedule until you did something for Washington State that proved, you know, we scratched that too because of you. Good thing.
Dave?
David Nard from the University of South Florida. Bob had a question about the coherence, the long strike versus the cross strike.
Yes.
Why is it so different?
Well, it's in the math, of course.
Of course.
Well, it's basically because if you have a constantly magnetized piece of crust, it doesn't produce any magnetic anomaly at all. And so that means that if you have a constantly, you're running, let me see if I can make it make sense. No, it doesn't make sense. I'm sorry, I don't really know the answer.
Catherine Constable from Scripps. I have a sort of similar question or comment for Bob, and that is, you said, of course, you all believed it and now I've proved it. But part of that seems to me to be because you were dealing with the ridge problem where you have long strike magnetic anomalies, and you have a whole different can of worms when you think about seamounts, where the spectrum of variability is, and it's in the ridge, a long strike problem, you have long wavelength structure in the long strike piece and shorter wavelength structure across the ridge. But in the seamount problem, is there anything, you want to comment on whether there's anything to save you there?
Well, I've written a lot of obscure stuff on seamounts. My conclusion is that you can determine something about the direction of magnetization of seamounts from surveys, which is, again, what everyone expects, but the thing you can't do with the normal methods is determine the uncertainty. And you have to put in a more sophisticated statistical model to get uncertainties out. And my rather depressing conclusion is that the uncertainties are really rather large, and they're not your directional determination of seamount magnetization. Really, the uncertainties are too large to be to make the data geologically interesting. Does that answer your question already?
Well, I just thought it was an important piece because seamounts also played an important role in...
I mean, you can surely tell where the normal reverse, but if you want to say, do something about the evolution of basins based on seamount magnetization directions, my conclusion is that the uncertainty in the directions is much too large to do a creditable job.
Thank you.
Travis.
Yeah, Travis Clow, I'm a first-year PhD student here at Scripps. I got a question for Dan. You mentioned that you moved away from backup basins some 40 or so odd years ago. And I know as a graduate student here, we all hope to have illustrious careers in science and have a lot of different avenues, but I just wanted to see if you had any comments about your career trajectory and what spurred on kind of quitting, so to speak.
That's interesting. I was going to actually bring up this as a little bit of philosophy. After, that Site 298 in the toe of the Nankai started me into really getting interested in accretionary prisms. And so I spent quite a bit of time looking at trenches and the whole 4R site. But then I got tired of going to sea, I guess. And I'd always been sort of interested in rock mechanics, if you call it that. So I built a big lab, 100,000 pound load frame, and started looking at mechanical processes of deep sea sediments. And the philosophy there is that I was scared to death going into a totally new area. And you know, it's logical to be scared like that, but don't let it scare you. Now, know you're going to be scared, but have the confidence that after a year or so, you'll figure out what you're doing. So, you know, you jump from area to area, but just realize that not only are you going to be scared, but you're also going to be, I wouldn't say despised, but you're not going to be accepted by people in that other field for a long time. And after I got done, I retired, I got into deglacial geology, and the same damn thing, you know. I know I didn't know what I was doing, but it's been 10 years now, and I'm starting to publish controversial papers, and some of the other guys will even talk to me now. So I don't know if that answers your question.
Tanya Atwater, I just wanted to tell you, Dan, I remembered when you figured that out, and I was really mad at you.
Figured what out?
About back arc spreading, and really disappointed because there was just a little rosy, maybe a year there that we thought as soon as we got all the measurements at the seafloor spreading, we'd be able to solve the whole world. And you put in this messy complication.
I was going to say that, you know, it was second order compared to seafloor spreading, but number one, it was a Scripps contribution, and it was kind of fun in the sense that people didn't want to believe it right away.
John DeSanto, student here at Scripps. So we go out to sea a fair bit, even today, some of us. Are there any ways in which the culture of conducting marine geophysical research has changed over the decades?
The answer is yes. I don't know exactly how to answer it. One definite change is that you were almost a cowboy back then, you know. You could damn near do what you wanted. You had to bring the ship in at a certain time, but there wasn't much background, and so you sort of followed your nose and that kind of stuff. And before my time even, it was even wilder that way. If you read some of the stories about Capricorns and those. And as time went on, it was more and more these detailed surveys until, you know, I think now you can almost run a ship with robots and then be back and forth on these surveys. I'm sure it's still fun and everything, but it's changed an awful lot. It's much more constrained now. And there are probably other things as well. I mean, we had UNOLs now, and so you don't have these expeditions from a certain institution to go out and come back, and everything's kind of copacetic and stuff. You're in there. I've been on legs on Hawaii ships and Woods Hole ships and everything, and it's just a totally different feel than going out in the old days on your own institution's own ships. So that's some differences. I don't know. I bet you people here can add to that.
Well, one of my comments, and you were absolutely the leader of this, is one of the things that was great about Scripps, and it's been that since probably the 1950s, is they sent people to sea and they just expected them to do something. And all that the guys had were sort of kind of a conceptual idea, and if you could connect with that conceptual idea, they'd give you the ship. And I mean, I'm worse than anything. I started as a chief scientist before I got my PhD, okay, in 1966. And then I think about how people progressed, and you basically were left on your own. And this was incredible because the people who prepared you for that, they'd also been in that way, like Bill Menard, like Bob Fisher, and all of these people. They were expected to produce it. And one of the things I think is the wonderful comment that Xavier Lepichon had comparing Lamont, okay, to Scripps. He said, Lamont had all the data, but Scripps had all the ideas. And I think it came from that.
Okay, but we really have to give credit to those marine techs, you know, Fred Dixon and Hohenhaus. We wouldn't have had a chance without those guys.
But Bruce, and then we'll go to Chris. Yeah. Good.
Bruce Langback. Yeah, I want to second that because I was a chief scientist graduate student also here, and we rely on the technicians like Hohenhaus. But the point of that is the senior professors, the senior scientists, were taking enormous risks by sending out graduate students. Enormous risks to their reputation, not to mention OSHA, which didn't exist then. The risks they take, you really have to appreciate what the senior staff did in those days.
Yeah, I want to tell a story about Vic Bartier and Bruce Hazen. The Scripps vessels did not have any chief scientists who went from Scripps, and they were told that they had to do this. So Vic Bartier was on the cruise, but he was not the chief scientist because it was given to Bruce Hazen. And Bruce went off from Hawaii, he went from Hawaii to Japan, and he started to dredge. And he dredged and dredged, using that dredging sap, sweating away, and Marie Clark was there pulling out all her charts, putting little dots in them. And Vic and I wanted to do seamount surveys. And we weren't getting anywhere, so Vic said to me, I think we're going to have a scientific discussion this evening after dinner. So we got all the scientists together, and Vic got up and said, well, it seems to me, Bruce, that you've proved you corroborated Ed Hamilton's idea that the mid-pack mountains were the Cretaceous in age. And Bruce thought about it for a while and said, I guess you're right. And so we went and did some seamount surveys after that.
I didn't know Bruce would take advice like that.
Tanya again, I would comment that that wonderful freedom we had was because there was good funding. Dr. Speaks told me once that the Navy just viewed anything we could find out about the ocean was of interest to them. And actually, Bill Menard told me once that he always proposed to do what he had just finished. So then he always, got a really good result.
Yeah, oceanography in those days was a little bit like, say, Antarctic research or maybe space research. It was looked upon as a national need, and so I never had a proposal turned down by NSF for the first 10 years or so. I mean, it was really a fantastic time, and one of the reasons I retired was that it wasn't that fantastic anymore. It took 3 times to get a proposal through. So we were really lucky.
Bob?
My name is Mark Fisher. It's been mentioned once or twice today. But I came in 1950, and we had a director named Ravel at that time. He became director in 1950. But I'm not going to want to give you a lecture here. But the problems you're talking about now and the questions reflected very much the directors of the institutions. And in those days, you had the 3 institutions. And the primary one in general attitudes was Scripps that had been started in 1898. And you had one called Woods Hole, came up in 1933. And then you had one called Lamont, which came up during World War II. And of course, it's gone on to that to be perhaps quite significant on the East Coast and other areas. But anyway, each of those had those throughout these years in the 50s and 60s had directors. And Columbus Island of Lamont, Woods Hole, was a sailor from right beginning to end. He was a wealthy man, and he was used to yachts, and he'd grown up with those. And Woods Hole had that tradition and did very fine work in oceanography and open sea things and so on. But again, in the tradition of that director in those years. And Lamont had Morris Ewing, who you've all heard about, who was a real adventurer, and I'm not going to tell Morris Ewing stories. Over the years, we knew each other quite well, and I will mention 1 or 2 slight things. One of the things that Morris had set up to make sure that you got lots of data was that every day when you're out there, you took cores and 1 or 2 other observations, and you tried to do that about noon. You didn't worry about positioning all that while, but you took it at that time. And as a result, Lamont built a very wonderful collection of cores. And to my way of thinking at that time, being at Scripps, it was a lot like the monkeys with the typewriter, and ultimately it would write something very, very significant. As a result, Lamont has a wonderful collection of cores, and the work they have done is beautiful. And yes, I knew all of those people. I'm not going to sit here and drop names about things of that sort. But I remember that about during the latter years of Morris Ewing's life, and I was back there, and I said, well, tell me, Morris, where are your ships today? And Morris looked me in the eye and said, gee, Bob, I really can't, I don't know. But one thing I am sure of, they are doing wonderful work. And I said, come off it, Morris. And I didn't have occasion to talk to him much after that. And then the last place, Roger Revelle. I'm going to speak of that time, and there are traditions here. There are people can talk to about it at lunch or whatever. The thing about Revelle, he picked people pretty carefully. And you hear about Scripps people taking out major expeditions when they were graduate students. And when I was here, I came here in 1950. I never was interested in the least my own work, what my professor would tell me to do. I had a professor, I had committee members, but they didn't in any way really. The one I had didn't bother to advise me. But I was able to get ships. And the thing about Revelle, which I said again in interviews, when Revelle would get you a ship, or you would get a ship, in whatever way you had to use it. Once you were out of sight of Point Loma, and you were out there for a month, or 6 weeks, or as somebody has mentioned, around the world, Revelle never in any way directed you. There wasn't any of this at noon every day, wherever you are, take a call. You were on your own, and as a result, various Scripps people went off to direct institutions. And some of you, I think, will know. I said I wouldn't give a speech, I did.
So I think maybe we have time for one more question, but then we're going to head out for lunch. Oh, take a photo, right? We're going to be. Where do you want to?
I'll say something.
Okay. Maybe just to put in one plug for if you've never been to the website, the library put together some very nice stuff on old expeditions. So, for example, I went in and dug up an old memo from 1967 where Bill Menard was basically appointed new chief scientist for that. In a short paragraph to run one of the NOVA expeditions. So there's a lot of good stuff there if you want to go look around. Yeah. Any more questions? No?
One quick one.
All right, one quick one.
From Roger Anderson. Dan and I went in Marianas doing heat flow a couple, 3 years after you got there. And we got profiled across the ridge, and the one that succeeded closest was the highest measurement I've ever seen, 18 microcalories, or whatever it was. And the next one, it came back inside the trough, and it came back as if it had been blowtorched. And I thought, what the hell is it, what happened to it? It was burned crisp. Do they have black smokers there now?
Yeah, is Jim Hawkins here?
Yep.
Wait, shit.
He dove one.
Did I stick a heat flow probe in one? Yep. I didn't fire it like this, you guys.
All right, thanks, y'all. So we are going to convene outside. We're going to have Jesse get